The last kind of graph we need to look at is called a scatter plot. And here I have some data on mountain bike rides I've done recently. And I don't go for very long rides. You know, the longest I might go on a mountain bike is 20 miles maybe. But I do a lot of short rides, and they range anywhere from a couple miles, depending on the ride, up to like, 4 or 5 miles. So there's a variety of recent rides here. And this is appropriate for a scatter plot because I have two quantitative variables that are related to each other. And that's when you do a scatter plot. So there's a lot of different situations. Sometimes one variable is time, but it doesn't have to be. So there's some more examples in the book that you can take a look at. So a scatter plot is where I treat each of these as a point. And so this first column is going to be like the x, if you remember that from your algebra classes, and the second column is going to be what we call our y. So x is my time in hours, and y is my distance in miles. And I want to plot each of these to the best of my ability. And I'll do that by hand, and then I'll try it on a computer. See how it goes. So first I need to set myself up a grid. And I don't think I want a red grid. How about a blue grid? So I have one axis. Ooh, how'd that happen? Fun with technology. All right, one axis for y, and another one for x. Close enough. So let's see. For x, I have a low of just under 1 and a high of around 2. So, and those aren't too far from 0. Sometimes you don't want to include 0 depending on how far the numbers are out from the axis. So in this case, I think I do. So maybe every 5 could be a unit. So 1, 2, 3, 4, 5. So deciding on the scale can often be tough. 1, 2, 3, 4, 5. What's that be? 2. So if I go by 5, then this is 0.2, 0.4, 0.6, 0.8, one whole, 1.2, 1.4, and so on. 1, 2, 3, 4, 5. So out here would be 3 hours later. So you should mark and label your axis. If you don't have graph paper, just carefully mark that out. A ruler is an excellent idea. If your scale isn't uniform, meaning the distance from here to here is 1 and that same distance is 1 over here, then the graph's going to get messed up. All right, vertically, we need to get up to 15-ish. So let's see, what would be a good scale there? How many marks do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess everyone can be 1. So 1, 2, 3, 4, 5. And every graph's, whoa, come on, pen. What's going on there? There we go. 1, 2, 3, 4, 5. That's 10 if I'm counting right. And 1, 2, 3, 4. That should be 15 up at the top. And this is my miles, right? Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so then I just try to plot these to the best of my ability. So 1.11, that's going to be around here, and then almost 7. So let's pick a different color. How about green? So right in between there, and again, this is 1, this is 1.2, so 1.1 would be right about in between. And this is, let's see, 5, 6, it's just under 7. So maybe my first point's around here-ish. 0.81, so 2, 4, 6, 8. Just like 5 1/3. So up from here, that's 5, that's 6. So maybe about there. Another point just above 2, and then 15.5. So 2.1-ish is over here. Go up 15.5-ish. So right around there, I think. Almost 1, just under, and a little above 7.5. So just under 1. maybe, see, that's 8, that's 9, so we're almost in the middle, and then let's see, 5, 6, 7, just above a half, so maybe over there. 1.44, so 1.2, 1.4, 1.5 is there, so 4, no, that's 6, that's 5, yeah, 4 is going to be closer to the line here, 14, almost 15, okay, so close to that line, and then up here, that's 15, so maybe here-ish, and then pretty darn close to 1, just above 10.5, so pretty close to 1, let's see, but just under 10 and just over a half, so maybe right there. All right, so those are my points. They kind of sort of line up. Let's see, I can have a line tool here so I can try. So some of the scatter plots we're going to look at in this section are going to have points that line up. Points don't always line up. I'll show you another example in a minute. Oops. Let's pick a red line and try and guess. So I want to take a line through here that kind of splits the difference. So what if I started on the last point and went to the first point? And then I can kind of tweak it. So I don't see a great line that hits just 2 points. So here I have 1 below and 3 above. That really doesn't split the difference very well. I don't like that line. Let's try a different one. How about, like, what if I went through this point and that point now? This point and that point. All right, let's try this one. Yeah, that's not too bad. It kind of splits the difference. 2 above, 2 below, 2 hit it. Yeah, let's ditch the red line. Delete or erase. And can I tweak this sucker just a little bit? All right, so I'm trying to hit that last point there, that the longest time, biggest distance, and I'm trying to hit this point here. All right, so which points are those? So let's highlight those suckers. I was trying to hit that point and that point. In my table, that would be this point here. And that looks like the 0.93, 7.6. Yeah, so it looks like I picked these 2 points. Sometimes when I'm trying to, if the data lines up, sometimes there are no 2 points that hit a line through them. So that's an estimate. I'll do another video where I find the equation for that line. But next I just want to show this in a spreadsheet. So I have those same numbers typed into my spreadsheet here. So I typed up my time in hours. I have an extra decimal point. My bicycle computer gave me a little more detail, but they're pretty much the same numbers. And so to graph bivariate data on a spreadsheet, you got to get it typed in. You should have titles that are relevant. Let's blow this up a touch. And then you highlight your data, including the titles. And then in Google Sheets, there's an Insert Chart button. You can also go to Insert and then Chart. And that brings up the chart wizard, which I'm going to have to zoom out a little for. Maybe. Okay, so the computer guessed at a scatter plot. It doesn't always guess right, in which case you got to go and scroll through and find the scatter plot and pick it. Other things to double check is sometimes it misreads some of the points, or if you don't have labels, it tries to pick the first line as labels. So if I'd only highlighted rows 2 through row 7, it might not plot all the points. So I should have 1, 2, 3, 4, 5, 6 points. And over here I have 1, 2, 3, 4, 5, 6. It doesn't look exactly like the graph I did, but that's just because I have a very different scale. So if we go back here, notice this, my screen over here is more square. Theirs is rectangular. So theirs is like theirs or mine is a skewed version of the other. But the points are in relatively the same position with respect to another. Let's see, they go from 1 to 1.25 to 1.5, so that means over here would be about 0.75. So again, if you compare that to my hand-drawn graph, they're graphing from right here over. They're not even showing this part of the graph. So again, graphs can look different depending on how you choose to scale the graphs. And the computer chose a different scaling than mine, but the points still kind of line up. It turns out we can ask the computer to draw a line. If you're an Excel user, I can show you, I would post another video on how to do this in Excel. So just for now, I wanted to get a scatter plot. A scatter plot is when we have two quantitative variables that are related to each other. And the relation between these two is I went for a bike ride and it took 1.11 hours and I covered 6.97 miles. Note, these numbers here is not 1 hour and 11 minutes. This is like 11% of an hour, which is different than 11 minutes. Often these apps for recording running times and biking times actually give hours in minutes, but that is way harder to graph by hand, so I just converted to just straight hours. Forget about minutes. All right, scatter plot, pretty straightforward. It's plotting points based on what we call bivariate quantitative data. Take care. See you soon.